Right, recording session number 2. Is that working? Yes.
I just thought we did. I just one.
No, that's fine. I wouldn't expect that. Right. Okay. So we've had a look at lofts. We're going to have a bit more of a look at lofts in this example in a minute. But before we do that, this part of the evening, if you like, or this part of the module is about surface modelling. Has anyone used surface modelling before in any of their models or played around with it? Yes?
I think so.
I think so. Sorry, quite a bit?
No, tiny bit.
Tiny bit.
It'd be very much the opposite. Quite a bit, yeah.
Sure. So we've looked at solid body modelling, and we've looked at all the different types of ways of modelling stuff. Surface modelling is occasionally extremely useful for certain things. I'm going to show you sort of a couple of use cases that I've used it for and why to use it and when to use it. But basically, surface modelling is just like solid body modelling. We'll have a look in a minute. You can loft things, you can extrude things, you can revolve things in exactly the same way. But instead of making a solid object, you're just creating a surface of an object. So let's just show you a surface. I'll rewind this. Oops, one too far. This is a surface. So you can see that object has got no thickness. Okay, it's just a surface. There are times when it's beneficial just to create surfaces rather than solid bodies. It may be that you're creating a really complex shape, multiple compound curved shape. It may be that you're creating very thin-walled sections and compound curves. And that's when surface modelling, in my experience, is particularly useful. If you think about, say, this instance, a spoon, like a pressed spoon, it's quite a complex shape when you look at it. It's got compound curves in 2 directions, 3 directions, and 3 axes, isn't it? And a pressed spoon might be the same thickness. It might be just stamped out of a piece of like 1.5 mil stainless steel. If you were going to loft this as a solid model, that's quite a lot to think about, isn't it? You might have to draw the thickness of that spoon all the way along, loft everything carefully, and try and get it to that even thickness whilst doing all these loft profiles that we've just drawn in the hammer. It could get quite complex, and surface modelling is all about trying to make things simpler, like anything in Fusion. What we can do with surface modelling, we can just model surfaces and then give them a standard thickness, for instance, would be one way of doing it. Another thing that we can do with surfaces, we can create complex compound curves that overlap, then trim those surfaces back to each other. That's called overbuilding. That's a whole nother area of sort of surface modelling, which I'm not going to go into now. I'm just going to show you the basics of surface modelling. I tend to use it, as I say, mostly for thin-walled modelling. I also use it occasionally to create tools for splitting bodies. So if you just want to cut something and you can't cut it using, say, a sketch line, or you haven't got a piece of geometry that exists, but you just want to cut something in a particular way, it might be simplest just to make a quick surface shape, whatever that is, and use that as a cutting tool. So those are my sort of 2 ways I use it mostly. It's for thin-walled stuff, and I'll show you some examples, and for making tools for cutting or splitting bodies, as we've just seen with that hammerhead. For whatever reason, if that top of that hammerhead handle, we wanted a different shape at the top of that, we might just do a quick surface loft or surface extrusion or something like that to create that shape and use that as the splitting tool. So those are the kind of use cases I find myself generally using it for. As I say, there are people that will spend all their time in surface modelling and will do sort of complex car designs using overbuilding of surfaces and trimming them back. I'm not going to show you all that now because that's probably almost a course within itself, but I'm just going to show you the basics of how I think it's most practically used and how you can sort of approach it. So I think for this one, I mean, you can have a try going along with me if you like, but if you just want to watch, that's fine as well. It's entirely up to you. It's going to be hopefully relatively familiar because, well, any ideas how this shape was created? I mean, you can kind of tell from the timeline, obviously. But any ideas how I might have approached creating just this particular shape? Any thoughts? I'll give you a clue. We've been doing exactly the same thing earlier on this evening. What kind of function? Is it an extrude? It's a loft. Yeah, I mean, although it's just a surface, we've still got to think in extrusions, revolves, and sweep and loft mindset. Could we make this shape from extruding? No, it's far too curvy and complex, isn't it? Can we make it from a revolve? Well, possibly, but perhaps not. Could we make it from a sweep? No, so what's left? Loft. So that's kind of, you always come back to, you can't make it any of those three ways, make it with a loft. So let's just turn on the sketches, you can have a look and see what the approach was here. So you can see the wireframe that I've created for this particular surface. We've created from a number of profiles, just like in our hammer, and one guide rail.
It's so simple.
And that's always the way, you're always trying to make it simpler and break it down. If something looks complicated, try and make it into little, easy to solve bits. But that's all that's driving that particular form. And then let's have a close look at how those sketches were created. Let's have a look at this first sketch, because it might look quite familiar. What does this look like? What kind of arc? Centre point arc. So I'm using the same thing I used on the bangle, and the same thing I've used on that hammerhead. Remember that curved hammerhead shape? To create these arcs, these profiles. The difference between surface modelling and solid body modelling, for surface modelling, I don't have to have a closed loop. I can just have that sketch, that single line. And that's all you really want, really, with surface modelling, is that single line. You don't want that closed loop. You can have a closed loop, and it will create a hollow surface, if you like. But, you don't have to for this. So that's a real difference. So that one was created, obviously, by a centre point arc. And this time I've specified the point between the origin and that centre point, and I've created that arc. I'm just going to show you that sketch. I'm just going to draw that sketch, because I just want to show you one thing I haven't shown you yet. I'm just going to create a new design, which might be useful. So just as before, I'm going to create a centre line for my arc, and this time I'll give it a value. And I'm going to create, the same way as before, this centre point arc, starting at this point up here, going somewhere over here, not defining that, somewhere over there, and I'll give this a radius of 100 millimeters. A bit wonky. How do I make it symmetrical quickly? Any ideas? Have I shown you this before? Any ideas?
Can you put constraints on them?
Yeah. What kind of constraint do you think we might put?
Equal.
Equal?
No.
No.
Coincident.
No. Symmetrical.
Yes,
So, yeah, it's a pretty obvious trick question, really. You've got a symmetry constraint, which is a really useful one to know about because it's quite handy. So if I click on that, and the way to do it, it's quite descriptive. You click on the two ends, and then the midpoint you want to be symmetry around. So I'm click on one end, the other end, and then this center line. And it will make it symmetrical. Now if I move it in and out, it will retain that symmetrical constraint. So symmetry constraints are really handy. I just thought I'd show you that, really, because it's a handy
If you
thing.
had selected the points the other way round, would it have shortened the longer part to match rather than lengthened the shorter part?
Good question. Probably. It would seem logical, wouldn't it? Yeah.
Sure.
Yeah, so there is a logical sort of order
But
to
the first selection is where you want it to go to,
that. Yeah.
and then it moves the other one to.
Obviously, you could ultimately define it. Define it by having, I think, could you do it like that? You could have some kind of dimension there as well. So, if you wanted to put some kind of definition, you could, or you could put in another construction line and have an angle between these two. If again you wanted to define it by an angle, and then obviously one's at 30 degrees and the other one would be as well. So So that's the way that that arc was created with that symmetrical constraint quite quickly. Okay. And if I go back to these ones here, all these were created in exactly the same way. You can see there's quite a lot of purple lines in there. So I projected geometry. So I decided to make sure that that center point I used to create this arc, I used the same center point all the way along. Didn't necessarily need to. That was my design choice. I could have had whatever curves I wanted to create that spoon shape. So let's just go back to this kind of wireframe. And what I was just going to show you is this sketch here. So this is obviously the guide rail, just like the one we've created for the hammerhead, the hammer handle curves. The difference with this one, it's got to connect obviously to each of those profiles, and that's really important. So if I just go back one, Fusion catch up with me, and I'll do that again. So I'm going to create a sketch. It's going to be on the plane that's perpendicular to the ones I've created. And what I'm going to have to do, if you remember, I don't think I can just hover over these and it'll pick them up. It would be nice if it did, but Fusion doesn't do that for you. So we're going to have to project those. So all I did was to go through these particular, I think it was the bottom. Let's just select the whole thing, these lines here. And all I'm going to do is bring in that geometry to this sketch. You can see we've got these little purple dots. Now I can snap my guide rail to those, and that's always the really important bit to remember to do. If I go to spline here, and go to the underside, and I just connect each one like that, you can see the spline automatically creates a smooth shape, which I can then manipulate should I want, maybe to make that a bit more curvy. But it's really important that that happens, and they're connected to each profile so that that guide rail will actually function. If you don't do that, you'll get an error when you come to loft it, because any guide rail has to connect to each profile. Can't miss one out. Let's just get rid of that one. So we've got to that point, and then lofting or revolving or extruding in surface modeling is exactly the same as in solid body modeling. If I want to go into the surface menu, up here we're in solid body modeling still, and we know that because we've got solid is highlighted here. Surface modeling has got its own toolbar, and you're in surface modeling because all the icons are orange, basically. It's quite visually easy to see, and any surface models or any surface features that you've done will be orange in the timeline, so you can quite easily visually see what's a solid body and what's a surface body. But you can see if we look at the surface modeling menu, it's actually a bit simpler. There's a bit less in there than with solid body modeling. If we look at the create menu, there's less stuff. We've got things we are looking hopefully now quite familiar. Extrude, revolve, sweep, loft. We've got a few other bits and bobs which we'll have a look at later on. But these are things you're going to still be using. We've got things like mirror, and pattern. So hopefully it's quite familiar, and all we've just got to think about is that actually we're not creating a solid body here, we're just creating a surface, but we're going to create it in the same way that we would approach a solid body. There's nothing to be scared of, is what I'm saying. It's not this weird and wonderful environment you're in, which is going to behave differently. We'll look at a weird and wonderful environment that will behave differently next week, which is the sculpted environment. That is really weird and wonderful. But that's for next week. So if I want to create a loft from this, if I go to the loft feature, it looks just like the loft dialog box we were using in the solid body modeling. And in the same way, I'm going to select my profiles, just work through them from one side to the other. And the guide rails again, I need to click on that if it's not highlighted and select the guide rail. So it's exactly the same process it's just creating a surface rather than a solid model. And we'll get to our loft like so. So from there, how do we create our cutout for the spoon? This is it's rather uncomfortable spoon shape. I wouldn't want to eat with that. Any ideas how we might go to the next step and cut something out from that.
Straight.
Could do.
Or a sketch of the outer edge of the spoon shape we want.
Yeah.
Like above.
Mm-hmm.
And then project it through to remove it from the surface, and then we can fill it.
Pretty much.
Okay.
Pretty much. I mean, it's exactly the same process we've just done with that hammerhead handle. We just chopped it. We can create a sketch above it and use that as a splitting tool to split a surface. In the same way we can split a solid body, we can split a surface. I'm trying to get across that it's exactly the same whether you're in solid body modelling or surface modelling. The same rules govern both of them. So, yeah, exactly that. So I created a plane hovering above, and then a sketch of the kind of spoon shape that I want to project down onto it and cut out with it. Let's just have a quick look at this sketch. And I'm just going to turn off things because it's getting a bit complicated to look at. Let's turn off the body. Now, if you look in the browser, I should mention this, any surface body will look like this orange unconnected cylinder. As you know, a body in the browser, when it's a solid body, just looks like a solid cylinder. We know this is a surface because it's orange and it's unconnected. Turn it off in the same way. Any idea how I'll have created this particular sketch? What? A spline. And what would I have done to that spline once I've done one half of it? It all gets very similar with CAD, doesn't it? It's same thing over and over again. So I won't redraw that now. I think hopefully we can understand how we'd approach drawing that kind of shape. But I've just drawn that outside shape. Let's turn this body back on. So what we can do now, in the modify menu, we've got the same thing as we have in solid body modeling. We've got split body function. And this is what I used to cut out this shape. So, same as before, body to split. Well, it's this bigger surface. What are the splitting tools? I've selected both sides of the sketch. You don't want to select it all in one go. And it projects or previews a cutout, sort of extrudes through it, if you like, and click OK. And now we've got two bodies. We've got the outside and the actual shape that we want ourselves, the spoon shape. So, splitting stuff, whether it's a surface model or a solid model, is a really powerful, quick way of creating a shape you want without cut extruding things. It's kind of a slightly more efficient and slightly more elegant way of doing things because it retains information that you can turn on and off. So, let's just turn these sketches off. We've got our spoon surface. It's a virtual model. It has no sort of thickness as it stands, so it's an impossible virtual model as it stands. We couldn't send this to a 3D printer. It couldn't print something with zero thickness, so we have to give it a thickness. One really useful tool within surface modeling in the Create menu, we got the Thicken feature. We can basically take any surface model and just give it a thickness. It only works if you want an even thickness over everything. But if that's what you want, then the Thicken tool's really useful. Very simple. You select what you want to thicken, this face, and then you give it a value. I'm going to say 2 millimeters. Let's make it a bit bigger so we can see it a bit better. Say 3 millimeters. I'm going to click OK. So now what we've got in the browser, we've got our two surface models, our surface bodies have switched themselves off. And as if by magic, we've now got a solid body. So you've got to remember, with surface modeling, this is only ever a means to an end. We're always trying to get to a solid body and then ultimately to a component so we can make it. So as soon as it's turned itself from a surface into a solid body by thickening, it'll turn itself into a solid body in the browser. It's kind of an automatic process. It's trying to help you to get to the solid body stage. And once you've done that, once you've got to that solid body, you can come out of the surface menu, go back into the solid body menu, and start doing other things that you might want to do to it. You might want to put fillets into it, you might want to drop text onto it, whatever you want. You can just treat it as a normal solid body because that's what it is. So thicken tool is really useful if you're just working with, you know, pressed stuff or, you know, things with even surface. But what if, oops, let's just do this, go wrong. Let's get rid of that. What if you don't want an even thickness? What if you want something else? You're going to have to create another surface, okay? And then you can join those surfaces together. And this is where surface modeling is really useful. You can kind of, if you want quite a complex shape, you can just build each surface up around your shape and then what's known as stitch them together. So for this example, I'm going to create, so what I want to create is a spoon with a thicker handle but a thinner cup, if you like. A lot of spoons might have that thicker handle to give it more of a balance, so, you know, when you're using them. So how do we go about doing that? Well, we could do a complete another loft. We could do a whole nother shape and go through that whole process again. That would be valid, but quite time consuming. What we could do is create a copy of that surface and perhaps change that surface. A bit quicker maybe. If I go back into the surface menu, there's a really useful function in surface modeling called an offset face, or an offset surface, where you can take one surface and just offset another surface from it. Now, it doesn't have to be a surface from a surface model. You can even do this from a solid body. You can just select any face on a solid body and create an offset surface from it should you need to. So it's quite powerful. So I'm going to click on offset, and it's asking me what do I want to offset. I'm going to click on this one here, and I'm going to give it a value maybe of 3. I'm going to turn the sketches off. So now we can see, it looks a bit like our thickened spoon, but it's just 2 surfaces offset from each other. So very useful, that offset surface tool, if you want to, especially if you want to split something, and you want to split it, offset it by a couple of millimeters from an existing surface. Very handy way of just grabbing any surface you come across, quick offset, chop it. For this example, however, let's just show you that. So I've got my offset surface. What I decided to do in this case was just to move that surface slightly. So there's no relationship between those 2 surfaces. It's designed as an offset surface or created, but it's not going to remain as an offset surface if you move it. Okay, so what we can do, like anything else, we can move things around. And I'm going to move this bottom surface away from the top one to give a shape. I'll show you what I mean. So I've selected the surface I want to move in my move copy function. I'm going to select my pivot point at the origin. I'm going to click OK. Now if I just turn it to the side, and I'm just going to, oh, that's a bit too much maybe. I'm going to give it minus, a bit too much. Something like that. So I've moved it, tilted it away. And perhaps now we can see, if I click OK on that, if I were to connect these 2 surfaces, I'm going to have a thicker handle. You can kind of almost see the shape, can't you? That you're going to try and create from just doing something as simple as that. Any idea what function we might use to connect those 2 surfaces? Sorry? Loft. It's all about lofting this evening, indeed. We're going to do a surface loft. Okay, we're not going to go straight to a solid loft. We're going to stay in the surface world. We're going to connect these 2 surfaces with another surface, a surface loft. So if we go to create loft, it's very simple. I'm just going to select one surface and then another surface. Click OK. I don't need any guidelines here. I could put guide rails in if I wanted to. But now I've got another surface. Now this isn't a solid body yet. It looks like it's a solid body, but if you look over in our browser, we can see we've got a number of surfaces disconnected, like so. Okay. So what surface modeling won't do, when you create these independent elements, it won't automatically stitch them together. It does with thicken, but the rest of the time it won't automatically stitch them together. So we have to tell it to stitch them together. And if you go over to the Modify menu, we've got Stitch and Unstitch. And it's also the button up here. And we just need to tell it to stitch things together. Very handily, we've got a tolerance here. So if your surfaces don't quite meet, you can just increase that tolerance. You've got little gaps, you can make them stitch together. But in this case, it should stitch together fine. So I'm going to select the surfaces I want to stitch together. I'm going to select all of the ones I've just created. So here's the first one. You can see there's a red line around it. That's because I haven't selected anything else for it to stitch to. If I select this sort of edge surface as the next step, we now see we've got a green line between these two surfaces we just selected. So that's kind of saying, yeah, that works. But we've got another red line down here, and we need to select that final offset surface. So there's 3 bodies, 1, 2, 3. And now we've got like a green line all the way around. This is kind of saying, yeah, it's okay, this will work when we come to stitch it. I'm going to click OK. Think about it for a second. And then now if we look in our bodies browser, once it's stitched those together and that stitching function's worked, it's automatically turned it into a solid body. Okay, so as I was saying, we're always trying to get to that solid body at the end, that final solid body, and then onto a component. So you can see actually, when we use surface modeling for something like this, it's relatively simple, but if we were to try to do that in solid body modeling, we might, and we wanted that thicker handle, we might have to have a profile sketch here of this shape. We might have to try and work out our profile sketches in terms of thickness as it moves along our spoon. It would be quite a lot harder to do. So that's the reason for using surface modeling, is to try and make your life easier. And it's understanding when it might be useful, I guess, is the trick. And that really just comes from a bit of time and playing around and reverse engineering stuff and having a go, really. Just undo that. There we go. So that's the point we're at, I think. So I'm going to show you some other examples of where I think surface modeling is really useful in a minute. But does that make, just as a real brief primer, does that make sense? Is there any bits that you need to go over again, or any questions about it?
In your timeline now, you have a thicken between your loft and your stitch. What was that bit for then?
That was for the other example of thicken.
Okay.
So that's why we've got 2 bodies in this example. One is just as a thicken, and one as the secondary way of approaching it. So this is, in your actual design, you wouldn't have that. This is for example. Yes?
I would like that spoon because I would like the bowl of the spoon to have a constant thickness, and then the starting of the thing of the
Yeah?
so I could make them to 2 components before I did the.
Yeah, so if you wanted to do that, how might you approach doing it, do you think? In terms of the solid surface modeling we've just done, what would you change to get to that?
Grant, I think I can.
Yeah.
Rather than doing a move,
Yep.
if you're moving the whole thing parallel,
Yeah.
what I do is I do one sketch for the top surface of the spoon,
Yep.
different sketch for the bottom surface.
And then do the cutouts for
Yeah.
the whole spoon? Yeah. Does that make sense? So going all the way back here to that original body here before, roll back, don't I really? Let's go back here. Yeah, so as you're saying, you've got this one, but then you want to make a completely separate one using other profiles, a secondary loft, if you like, because that's a more complex shape, isn't it? What I did was a bit of a quick, make it thicker. But yeah, if you wanted to do that, you'd have to then match some of those profiles, perhaps down here, so even ones underneath it, and then start moving away to a thicker loft. And then you'd have 2 surfaces, one on top of the other, which you would then cut through with your cutout. And then you could loft around the edge and stitch it together.
If you wanted to have a spoon with a cylindrical handle, would you just, when you did your original sketches before you created the surface plane, would you stop it short of, so you'd have like the head of the spoon, and then once you've done all this bit and created a solid body, add an extra thing and then do a solid loft to connect the two so that you had like a smooth transition from flat to cylindrical?
You could do. This wonderfully, Charles, you've segued beautifully into next week's session, which is all about the sculpt environment, where I've got exactly that example, where you move from basically this thin shape into that circular shape at the end.
Yeah.
You could do this with lofting, but with that shape, actually, you probably have to do it with solid body modelling rather than surface modelling, because if you think that circle at the end of your spoon and create that to a curve at the right curve at the front of your spoon, if you like, that's not really a surface operation, that's more of a solid operation.
Oh no, so yeah, that's what I was thinking is, do you go a little way into the handle at this point, but you wouldn't have, so where yours at the moment is cut up into say 4 sections of sketch, would you cut the last bit off? And then once it had been converted to a solid body, then do...
Possibly. The only issue with doing that would be nice to get a nice smooth flow between the various lofts that you're doing. But yes, you could do that.
Of course, yeah, because
yeah, and it's whether or not
this way
you
rather than just this way.
yeah, which is why when you start modelling it, you've got to try and work out what is the best way of modelling it. Something as specific as that, what we're going to look at next week, which is the sculpt environment, is the ideal way of modelling. You get a really nice blended smooth surface. There's absolutely no reason you couldn't do what you were suggesting with lofting, a mixture of surface modelling and solid modelling. But I think that one, sculpting, is actually what you'd need to do. And as I say, we've got exactly that example, which is just quite bizarre that you picked up on that for next week. So by the end of next week, once you've seen the sculpt environment as well, you'll have all the solid body modelling, hopefully, a bit of surface modelling and the sculpting. Then you can start to think about, well, which is the right workspace to be in, depending on the exact shape you want to do. And it's never easy, and it just takes time and practice to work out what that is and playing around. But yeah, you could do either way.
I've got the spoon-shaped surface, and I want to do the move to give me the second. I've gone into move, and I've got my 3 axes. I haven't actually selected the body yet. As you move around, it always keeps it perpendicular to the surface. We don't have anything flat on this.
Yep.
So as I'm moving my cursor around, the axes are moving. How do I get those so that they're vertical, so that I can move that up vertically rather than coming off at a strange angle?
Yep. Okay, let's just... So we're at this point here. You've got your second offset, yeah? And
no, I haven't.
You want to move that one away?
Sorry, I thought to get to the next, to get that up to the second body there. I've got one body.
Okay, so you could do it as a move copy, I suppose, but I did it as an offset to show you the offset function.
Okay.
So I did an offset surface first.
Surface. Is that the surface offset?
Yeah, so that is under create menu, offset, that one there.
Yeah.
That will give you basically an offset there. So
I was following through your timeline in that, and what you do after that is a move.
that's right, directly after that.
Yeah.
You probably could do that as a move copy actually and save yourself a step, but I wanted, as I say, show you the offset function. Then, to answer your question about the move copy, so yeah, you're right. As I sort of hover over this, it kind of moves around, doesn't it? And it's a bit annoying. So my approach to this is to, if you have your origin point switched on, so you can see that. So I'm going to select my body, no matter where. Now this is an odd angle, you know, this is the pivot point. If I start to rotate this, it's not what I want. So I need to set the pivot point somewhere else. So if I click on set pivot here, and then click on the origin point here, and then click done, now I can get it from there and move it like that. Now you can set that pivot point. If you've got other geometry, you can select any kind of point that you can select as that pivot point. And often what I'll do, if I want to move something in a particular way on a particular orientation, I'll select two things. The first of which being the way I want to orient it, and then deselect it, and then select the other thing, and it sets your pivot point, if that makes sense. That's another way of doing it, but you can always just set your pivot point wherever you want, basically. The only slight awkward thing, as I say, is you have to remember to click set pivot point, click your pivot, and then click tick. I don't quite understand why you have to have that tick at the end of it, really. It seems to be an extra thing that you don't need.
Whereabouts is the surface offset?
Under create, offset, surface offset.
Helps if I'm in surface.
You do need to surface modeling mode, absolutely. What I'm going to quickly do now is just show you some examples of stuff that I've designed using surface modeling to show you, where I thought it was useful to use it and where it wasn't. So I think, let's see, yeah, let's have a look at this one here. So this was something that we did for a student some time ago. She brought in this little sort of brass model of this Miles M52 experimental supersonic aeroplane that was made in the 1950s or something like that. Her dad had worked on. She was trying to reverse engineer it. And you can see there's a lot of surface modeling in the timeline. It's a solid model, but any ideas why surface modeling might have been useful here? If I spin around, any ideas?
Wings.
The wings, and why would it be useful to do that with surface modeling as opposed to solid modeling?
The curves themselves.
The curves, you could do the curves. You could do the curves as a solid loft. I guess there's one particular sort of thing about these wings. They came down to a very, very fine point, basically. They're almost razor sharp on that model. So if you're trying to do sort of really sort of fine razor sharp stuff in solid body modeling, it can get quite tricky. So I felt this was simplest to do as a series of surfaces, then join them together. Just because it was quicker and easier to do. I'm not going to unpick it all and show you the detail of it in too much detail, but if we look at perhaps, let's rewind and just look at what we've got here. Let's look at just this this sort of top rudder piece. What we've got within surface modeling, we've got a patch function. So if you've got just a sort of a connected series of sketch lines or geometry, you can, and as long as they're all connected, you can select them and it will just patch it. It's not even like a loft, it's just filling in a three-dimensional space, which is a really useful tool. So here we've got a sketch which is just on a normal straight plane, side-on view of that rudder shape. In the surface modeling, we've got something called patch, as I say, and it literally just patches stuff. So if I click on that, here's the surface. It's just a patched surface, okay? But what we can then do is, if I click on that and if I look at, I've created then a secondary sketch, I don't know if you can see it down here, just of that section, side section, that kind of aerofoil section on one side. And I've just done the same thing, I've just patched that as well. And here's the really good bit. Now I can go around and select this piece of geometry, this geometry, all around here as one piece, and patch that as well. It's a really very simple way of doing some really quick modeling without having to do all the whole lofting thing even. It's even quicker. So that final patch has got that kind of curvature to it. And then it was a case of stitching it together to turn it into that thin, solid body. That makes sense. So, I mean, it's a really simple way of modeling. You're just making sure all those lines you want to patch are actually connected, clicking on the patch tool. You don't have much sort of manipulation over that patch. It's just going to fill in that space. So if you want more curvature in there, which isn't defined by that geometry, you'll have to put it as a loft and guide rails. But in this instance, it was just right. It got an exact, or very close to the original model. And then it was just mirrored over. So it's all about making it as simple as possible for yourself And that's a really beautifully simple way of modelling if it's appropriate for you. And that's basically the way most of that was done, was with patching. I think I did one loft. I think I did a loft of the wings. It didn't quite get the right shape from just patching it. So I did a loft in that, and that one there. And then I think there was just another patch over here, done in the same way that I did this one here. So just a brief run through, but hopefully you can see how quickly that was done in using just a bit of surface modelling rather than solid body modelling. And why? Because it would be tricky to do with solid body modelling. So that's when I'd say go to use surface body modelling when it's simplest. So that's one example. I thought I'd just show you another example, which I'm going to have to just nip over into. Bear with me. And so, okay, where is it? Try this one. So this was a project we did months ago now for a guy that lives in Princetown. He's got a shop in Princetown. He's also he's a polar explorer, and he does polar exploration consultancy, training, equipment. And he had created about 12 years ago a human-powered polar expedition vehicle. Awesome. And basically this is a quadjack, and this enables you to drag it across ice, but it would also go into water, which means you can basically go wherever you want pretty much within the Arctic regions. He had created one of these with a company called ProDrive about 15 years ago, and he got 3 of them, and they'd been used in the Arctic regions for polar expeditions, but he wanted to reverse engineer it. He wanted to make a new, better version. All of the drawings and original handmade models, it wasn't CAD designed in the first place, had been lost. He didn't have access to those original drawings. We just had the thing itself. So he came to us to say, can you reverse engineer it, create a 3D model I can then take on to the engineers as the starting point to redesign what we want to do with a new, better, improved version. Any ideas why I might have chosen surface modelling for something like this?
There's nothing smooth on it at all, or nothing regular. It's all just
Yeah. It's a complex shape. That's one thing. I might just mention this was made out of composite material. It wasn't actually carbon fibre. It looked like it, but it was this strange composite material of Kevlar and other bits and
It was
bobs.
in here a few months back.
Yeah, it was in here for about 3 months or so.
Yeah.
Any other ideas why I might have chosen surface modelling to create this shape? And this you wouldn't necessarily know without seeing it, but how it's made.
Variable thicknesses of the material, in fact.
Well, yeah, although the other flip side of that, all the material was about 4 millimeters thick throughout the whole thing. It was one thickness. There weren't variable thicknesses at all. There was no internal structures at all. It was just that external shape which had been moulded in 2 halves, and it was split along this sort of, this split line along here. So that was one moulding up here, and that was the other moulding down there, about 4 mil thick. So, well, why bother trying to loft all of that thickness? That's a lot of work. I just want to create that surface model, and then if I want to, I can thicken it to give that, constant thickness. And that's one of the real uses of surface modelling.
But also, the way they'll make that is they'll make a mould for the fiberglass. They don't care about the thickness of it. They just need to know the shape.
Yeah. Which is exactly why I haven't actually thicknessed it at all. I've left this as a surface model. Usually I would give it to someone as a thickened model, but I had no idea what kind of thickness their new improved version might be. So I'm not going to put a thickness in. They can do that once they've decided.
That's hollow within its skin.
Yes. So that's a hollow shape.
No, I mean within.
That's just a surface.
Yeah.
That has no thickness. I passed it on to them without thickness intentionally. I normally wouldn't do that, but actually it made more sense for them to have it. To create the mould, and yeah, they could say, right, with this new material, we don't want it to be 4 mil, now it could be 3 mil. I don't know that, but they could then add that thickness and create a mould with that offset built in easily enough.
So what was your process for creating this? Was it a case of taking images, side, top, bottom, left, right, and then kind of drawing around it? Or?
what it was,
Photogrammetry.
yeah, so scanning.
So I was going to ask that, so I've got a VR headset.
Yeah.
I want to do a custom faceplate for that,
Right,
but it's all curves.
yeah.
With clipped, you'd have to clip it on top. So kind of thing of photogrammetry, but I wasn't too sure they would be better. But it seems like that's the way to go.
Scanning is very helpful, certainly. If you want to do something like that, we've got high-end scanners here,
Right.
which this was done with a sort of low-res handheld scanner, because our high-end scanner didn't have a big enough field of view, as it were, to capture this object. So you can see these different colours are different scans, which then had to be sort of joined together. I did also measure it and do it sort of the traditional way as well, and double up that scan to make sure that that was as correct as possible.
Blender will do it quite well.
Yeah.
A little dabble.
Yeah.
Yeah, in Blender, so if you don't have a powerful 3D scanner at home, you can do cameras and things. You can get quite good results, but there's more refinement.
Yeah, there's quite a lot of good free scanning software out there now. So things like Meshroom,
Yeah, that's
you can take just normal photos from mobile phone, put them into Meshroom, and it will create some kind of 3D model. Won't have the resolution of other higher end scanners, but if that's all you need, then yeah. But yeah, to answer your question, I started off with scan data as a starting point.
Right.
From there, if we just turn on those and turn off the scan so you can see it. If we look at the timeline, which is a bit messy, I will admit, 'cause I kind of working it out as I was going along, but you can see it's all surface modelling, and I just broke it down into elements. So how was I going to approach doing the side? Well, that was actually just with a straightforward surface extrude. It was just a straight down from this top curve along here, just extruding down. So I broke it down into panels, essentially, and worked out the best way of sculpting or surface modeling each panel. So then let's have a look at this one along here. That was a loft. We can see that was a loft in the timeline. It will have had a profile here, various profiles to build up that loft, and there's one of the guide rails. So the same as we just done, it's just breaking it down into a series of easier to sort of solve elements and stitching them together. And if I can rewind, I'm not going to rewind it because it will take ages to compute, but let's just have a look at, say for instance, if we see this surface here, we have a closer look. It comes all the way down a bit further than it originally was going. And then if I look at this one here, you can see this surface goes a bit further than it needs to. And where the two meet, you can trim them together to get them to join. Okay, and that's what's known as overbuilding. You're creating surfaces bigger than you need, making sure they overlap, then trim them back in the same way that you would with pieces of fabric almost, or something like that. And I worked around each part and just tried to work out what the simplest way was. So here's another loft for this section here. This section here was just another extrude. It's just a straightforward extruded off a single sketch. So whilst it looks like a complex curve shape, we just break it down into simple bits and just work your way through it one by one. That being said, it wasn't that easy, I have to say. But if you look at it, it's not that different to the spoon, really, is it? The spoon's a simpler curved shape, but this is the same kind of thing using the same processes. And yeah, it's the same for all of these elements, really. Mostly lofts. Here's even an occasional little sweep just for this little section here. And again, the whole thing was overbuilt and trimmed back to each other, stitched together, and then a few fillets put in to smooth it off. Things like that was filleted. So hopefully familiar features that you've seen throughout the course are being used time and time again, hopefully. So that was one example of surface modelling. I'm just going to show you one last one. Really, I want to introduce this one because it will sort of play on into next week as well in the sculpt environment. So let's have a look at this one. Okay. So this was another project we did for a client, and this was a wonderful project, still working on it, where we're having to take Lego Lego vehicles, Bluetooth-controlled Lego vehicles, and redesigned body panels for them, basically. Wonderful. If you're a little kid like me, still likes playing with Lego. This is actually for a serious purpose. They're trying to make a demonstrator for their hardware and software, which they create for incident response vehicles. And they want to make this environment which shows how their hardware and software works on a scaled-down model, so they can show clients, what works. But they came to us saying, we've got these Bluetooth-controlled Lego vehicles. They look like rally cars and monster trucks. We want to turn them into things that we recognize, like incident response vehicles and just normal cars. Can you do it? So my job was to take this rally Bluetooth-controlled Lego crazy-looking vehicle and just strip it back and then design body panels for it. Okay, so any idea why I would have used surface modeling for this?
So it would be injection molding.
Well, this was actually 3D printed.
Oh, all right.
These were just, low runs.
Lot of thin plates.
Exactly. It's thin wall stuff. All of this stuff was, I think, about 1.5 mil thick. It's only a small thing. 1.5 mil thick, thin walls. So again, same as the Quadjack, it's surface modeling for that very specific purpose. Not all of it done. Some solid modeling was in there as well. But again, it looks complex, but then if you start breaking it down, it's not that complex. I think that's the point of showing you this. For instance, this side panel here, that was just a straight extrusion, straight down surface extrusion, nothing fancy about it. This windscreen here, any ideas how this would have been modeled? What process would surface model? How would we create a shape like that? A loft? Yeah, a lot of lofting because it's quite a complex shape. Where would the profile sketches be, do you think?
Be vertical and like that.
So what, this one?
So, no, the top.
This one?
Yeah.
And then this one?
Yes.
Exactly, yeah. So loft profile here, and there might have been a guide rail in there. Maybe one there and one there, possibly, I can't remember. But again, relatively simple when you break it down into individual components. So roof was a loft, that's a loft, that's a straight extrude. That was just a loft. It looks a bit more complex, but just a loft again. And it's the same all the way around. So you just break it down into individual panels and loft them using surface. And it's, as you can see, hopefully not that complex to deal with. It looks complex as an end result. It's not. That's my contention anyway, hopefully.
To make it fit onto the vehicle, did you create a 3D model of the vehicle underneath that? Just to simplify the...
I just picked up the contact points. So I didn't scan it because I knew that wouldn't be accurate enough to sort of snap things to.
And Lego's accurate enough in itself.
Lego's amazingly accurate. Yeah. And Lego's really reliable. You can sort of, exactly what certain lengths of things are going to be because they repeat. So it's quite easy once you've got that in there too. It took a bit of time to get the tolerances just right to make sure it connected just so. But after a couple of 3D print tests, make sure it worked, it actually all snapped together quite nicely. So it, yeah.
Would you not get them to supply you with a drawing that you could insert, not derive?
A drawing of what?
Lego.
Oh, Lego. I didn't even ask. I wouldn't have thought.
Did they not give you one of the cars?
Oh yeah, I got one of the cars. Yeah, they gave me a car and I just reverse engineered enough of that. I had to, with that one, I had to take the car apart a bit and try and
Lego
work
are
out.
really protective of their...
Yeah, I didn't even bother trying with Lego.
I think I know what the answer would have been from
So
them.
say it wasn't Lego though, say it was, what would you ask for? Would you ask for DWG drawing?
No, DWG drawing's a 2D drawing. I would ask for like a step model or an IGs, which are like generic 3D parasolid modeling file formats. So Fusion's like an FDX, I think it's more, but that's specific to Fusion. And SolidWorks, things like SLD PRT files or things like that. Step files or IGs are the two most common ones, which you'll find on any, if you go to a manufacturer and try and, if they've got downloads of 3D CAD models, that's what you'll find. And Fusion can import those, or any CAD software can import that kind of stuff, really. You won't have timelines or anything like that, and it will just come in as a lump into your workspace, but you can still then change it and manipulate it from Let me just run through my list of things, make sure I've actually talked through everything I was meant to. Yes, I have. That's good. We're almost at the end, but I thought what I would do is just show you one extension piece if you want to do some more stuff at home and play around with surface modelling. Good. Let's just close this
I
down.
want to ask, should we record it as well?
Yes. Hopefully this is recorded correctly. That would be good. I will find out the best way to show. It's going to be quite a big file. I might get it hosted on the Smart Citizens website, so it might take a day or two to come through.
That's like molds as well.
If you're actually recording, your OBS icon should be green. I'm joking.
Bastard.
Is that recorded?
That is recording. It is recording. 55 minutes and 44 seconds. And
You'll have to write a form out now.
yeah, thanks for that, Charles.
So surface modelling also be good for making molds. Is that a good method for mold?
It depends on how complex mold is. No, I mean, mold making is actually, if you think about, if you've got the male and you want to make a female mold from it, what do you think, what tool might you use if you've got that already modelled male shape? What might you use? Sorry? No, because that's in the 2D sketch environment.
I don't know, we saw it earlier.
Yeah. Sorry?
Would you split the bubble?
Well, you could split the body. I can't show you this quite.
Did you see the first one?
I can show you this. I've got the example.
I think you showed
I was going to show you, before I do that, I'll just show you the extension piece.
Food in the middle, box around it, combine.
No worries.
Get the net.
Yeah, like we did.
Yeah.
So this is just the extension piece. If you want to do some stuff later on, or between now and next week. This was a little logo that I created for my own bike that I took apart and did over the pandemic and sprayed it all up. Anyway, I wanted to create my own new logo for it. Have a look at how this was drawn and have a go at using, this was mostly done using the offset modeling function. Have a go at doing that and seeing how you get on. It's also got reference canvases in it, which we're going to have a look at in more detail next week. But you can pop in reference canvases, JPEGs you take off the internet, as a place to start tracing from, if you like. So that's what this was based on. I won't give it all away, I won't run through it now, but have a go at doing that. There's nothing in there that we haven't done today, apart from looking at reference canvases, but it might be a nice little challenge to have a go at. In terms of your mold making question, I'm just going to, because I think we've pretty much finished the surface modeling, I'm just going to stop the recording and we'll look at mold making.